what's going on? Hello, class. I want to take this time to make a video about learning how to do the distance and the midpoint, but also to instruct you on how to use Desmos. Desmos is an awesome tool for us, and we're going to try and use it throughout the semester. Since we're all online, we might as well use an awesome tool that can help you understand mathematics in general. So here we go. Let's share my screen. There we go. Start the recording. Let's start to share my screen. Here we go. All right, so we got our distance and midpoint, one of 6 here that I wanted to go over with you. Let me make it a little bigger. There we go. So that way we have this, and I don't want Zoom open, Andre, come on. So there I am on the first video, starting off a little poorly. Okay, so we got Desmos open. This is desmos.com, DESMOS.com. Is an awesome thing, and you just hit calculator and it gets you to this spot. Trig itself is a very visual mathematics. So I want to use this to help us try and visualize the things we talk about, for instance, like distance between 2 points. Let's talk about that in a second. So what is this? And actually right now, let's go ahead and go for it. All right, so we got distance formula between 2 points. Right, if you have 1 point, so this is just 1 point. Think of actual numbers here. Here's an X, here's a Y, here's another X, here's another Y. I have 2 points, and we can find the distance. So this is notation for the distance between those 2 points, right? This is P1, there's P1, and P2, there's P2. So if I wanted to find the distance between 2 points, I can use this convoluted equation here with the square root and the squares and all that stuff, but nonetheless, all this is really Pythagorean's theorem. So let's kind of explore that with this first example. So I want to find the distance between the points 1, 3 and 5, 6. So if we remember, the Pythagorean theorem says a squared plus b squared equals c squared, or in this case, d squared equals a squared plus b squared. The distance squared is between those 2 points. So what are we talking about there? Well, let's look at these 2 points. Let me graph these out in the plane. There's 1 point, so I'm making it up in Desmos. You can see it came up in Desmos, and then 5, 6 is another point in the plane. There's another point. So there are my 2 points. Let me turn on projector mode to make sure that we got this, so we can see this. And I can even zoom in a little bit here. There we go. So we got 2 points in the plane. I want to find the distance from here to here. And the shortest distance is like this. The shortest distance is on the line there. So technically, if I create the equation of the line here, so let me just do that really quickly, and it's not a big deal if you're not sure where I get this from. So I'm going to subtract off 3, y minus 3 equals, and my slope would be, what would my slope be? I can do that math over here. So if I do 6 minus 3, let me do the fraction first. I'll do 6 minus 3 over, and then we do 5 minus 1. 5 minus 1. That is my slope formula that I'm using right there. Y1, y2 minus y1 over x2 minus x1. So that is my slope. I don't even care what it is at this point. So, and then I'm going to multiply by x minus the x value of this point, because I use the y value here. I'm going to subtract off the x value, and this will get me a line through those 2 points. There it is. I can even truncate that line. So I'm just showing you a little extra bit. I'm truncating that line so as to say x has to be between. So let's make it between or equal to. So I'm using the inequality, the less than symbol, and equals to make the less than or equal to symbol. X less than or equal to my y, my other x value, which would be 5. So from one x value to the next, I'm saying that this function, this thing that I'm creating, can only go from 1 to 5 in the x axis. So it kind of truncates it and makes it so we can see what's going on. So, and why not? I'm going to change the colors here a little bit. Boom, boom, boom. Trying to teach you a lot about Desmos so we can see. So what we're doing and what we're trying to do when we determine the distance between the points is finding the distance of this line right here. right? And if I had a measuring tool, I could just measure it, but I don't have a measuring tool. So let's try and figure out some mathematics that I can do in order to do this. All right. So what if, so what I really want to do is use Pythagorean theorem, because I can see that this distance right here, which is the distance between the x values 5 and 1, which is 4, and the y value, this distance here, make up a right triangle. So with the knowledge that this is a right triangle, we can use Pythagorean's theorem. So let's talk about that for a second. So let me do that, and I'm going to do it here on my surface. So let me bring my surface into play and let me annotate. So here we go. So I'm going to find the distance there, which I know is 4. I can see it on my thing, but nonetheless, let me show you what we are doing, right? I'm taking the value of x here, which is 5, and I'm subtracting the lower value, which is 1. So we get a distance of 4 in the x direction from here to here. So it doesn't matter if it's -4 or +4 for Pythagorean's theorem, it is a distance, so it should be positive. Now let's do the y. So y distance here, well, what am I starting off at? I'm starting off at 6, so I'm going to take 6 and I'm going to subtract off the lower value, and that is 3. So I'm going to take 6 minus 3, which is a distance of 3. So let me go back now and just try and get my eraser going. I just want to clean this up a bit so we can see it a little bit better of what we're talking about. So what we're talking about here is a right triangle with one leg being 4 and another leg being 3. This is a right triangle because that is a right angle right there. So Pythagorean's theorem applies, right? And Pythagorean's theorem says, if this is C, but I don't want to call this C really, I want to call this D as the distance. D, so I could say a squared plus b squared equals d squared is what Pythagorean's theorem says. A squared plus b squared equals this hypotenuse squared of my right triangle equals d squared. And we can see this matches up with this equation that we have over there. It really is just Pythagorean's theorem. And all we have to do is now solve for d. How do I solve for d? So, well, this is 16 plus 9. That equals 25. So d, right? D, that 25 is d squared. I take the square root. Things to kind of note here. When I take the square root, typically you need a plus and minus. So if I take the square root, and that's all of mathematics, when we take a square root, we need to make sure that we're being honest and understanding that typically there is a plus and minus that comes involved when we take a square root to solve, because not only does +5 become a solution, but -5 is a solution. So I'm saying this, but hopefully you're yelling at the screen going, Andre, seriously? Why would you say that? Because this is a distance. This is a positive thing. This is nowhere, it couldn't ever be negative. And that is true. So there's no way this could be negative, but I want to make sure we're honest with ourselves in terms of the mathematics and the way we solve things. And this is one of the things that causes students problems. So make sure you understand that when we solving things with a square involved, right? When we take that square root on both sides, you get a plus or minus feature going on here. And we have to make sure that we have that minus sign just in case, right? Just in case there could be the possibility that it could be negative. All right. So, but now we know it's not negative. We don't have to worry about that. So this is +5. D equals 5. Our distance equals 5. All right. That's all fine and dandy. All right, so hopefully you get that. I am going to erase my annotation now, so that way we clear this up, clear all drawings. There we go. So let's go to the second example and talk about this distance formula, because we can actually do this distance formula. And oops, I'm still annotating. I just realized that. Clear all drawings and get rid of that. So let's go to our distance formula in the second example to see how to find the distance between 2 points. All right. So with that in mind, let me get rid of some of these because we got new points here. So let's put in our new points. I want to find the distance between the points 2 comma negative 3 and 7 comma negative 5. We can use Pythagorean theorems. I am not going to force you and to use the distance formula to show me how to find the distance. I am going to let you possibly use Pythagorean's theorem, because to me, you understanding Pythagorean's theorem is way more useful than you understanding the distance formula. Although, let me say this too, the distance formula actually bumps up to 3 dimensions as well. So, that's kind of cool, right? When we got X, Y, and Z as well, we can do the distance formula, and it is really just an addition of the subtraction of the Z's at that point squared. So it really does. It's pretty cool. So hopefully you get that. We're not, I don't think we're going to talk about it in this semester, but in future semesters, we'll talk about the 3rd dimension and help you with that. So let's go for this. Let's talk about these 2 points, and let's go ahead and create that line again to talk about the distance. I like visualizing. That's all I do. So that's all I want to do is help you visualize it, because like I said, this is a very visual topic. Trig in particular is very visual, and so is distances between points. I am looking at these 2 points. They graphed it out here for me. I got these 2 points. I want to do this. Let me just label those just to make sure we got those labels. And let me make again a line so we can understand that we are finding the distance on the line. So y minus, so I'm going to use this top point. This is called the point slope form of a line that I'm using. So I'm going to subtract off the y value from that point. Oops, it's not 5, it is 3. So I'm subtracting the subtract. I'm subtracting the negative 3. So there's that, minus the slope. All right, so I'm going to take the slope. I got to find the slope. So I'm going to let Desmos do this stuff for me. So y1 minus y2, y1 minus a negative 3. Whoops, and I forgot that Desmos likes to make fractions with just one number. So let me show you, if I do that minus 3 that I want to do, and I try to make the fraction, it just makes it on the 3, and I want it to be over the whole thing. So I'm going to do 5 divided by, that way I get the fraction set up, and I'm going to subtract a negative 3. So those are my 2 y values, 5 minus negative 3, and then I'm going to do 7, right? The x value associated with 5 right underneath it, and I'm going to subtract off 2, which goes with the negative 3. All right, there is my slope. That is my m. And then I'm going to multiply by, in parentheses, x minus the x value that is associated with the negative 3, which is 2. So I'm setting up the equation of the line, and I can even put some parentheses around there and make x go between the 2 x values, 2 to 7. So 2 less than or equal to x less than or equal to 7 is the number. I forgot already. Whoops. I don't need parentheses. I need the squiggly brackets to set up a set. This is a set notation that we're using here, and Desmos understands set notation. To make it I'm just trying to make this look nice for you. So that way we can see it and kind of visualize. We are trying to find the distance of this line from here to here. Exactly. So we can look at right, the triangle that we're doing, and we can use Pythagorean's theorem to help us, or we can use this square root to find that the distance is the square root of 89. So, so just to kind of show you Pythagorean's theorem, since Professor Policino kind of provided this example over here to show you how we would find this distance, let me show you Pythagorean's theorem, which is the same thing. So let's do that. So let me annotate again and show this example. So annotate. And so we are looking at this distance, right? This distance in x, the change in x, which would be from 7, right? This is 7 to 2. 7 to 2. 7 to 2 is what? Oh, that's 5. So this distance is 5. So let me erase that because that was a horrible 5. And let me come up, do the curve. So 5. How about the y's? What's the distance between this point's y and this point's y? What are the distances between that? This point's y is 5. This one's negative 3. If we just subtract those off which sometimes confuses students. So I just want to make sure we understand. I am subtracting off the -3. So making an addition. If we think of going past 0, right? So this is a distance of 5, and then this is a distance of 3, and we're really just adding those two numbers together to make sure we understand the mathematics there. All right, so that distance is 8. Let me clear that and make it cleaner for you. Boop, boop, boop. Got to make some noises every now and then. 8. So there is Pythagorean theorem set up with a D or a C over there. I don't care what you use over there, but that was a horrible looking D. So let me redo that, make it a little bit prettier. There we go. So D squared equals 5 squared plus 8 squared. There's Pythagorean's theorem. I'm going to take the square root of whatever the addition of these two things are, which is 25 plus 64, which is 89. And we're going to take the square root of this is D squared, right? All of these are D squared on this side. Now I take the square root and right, plus or minus, but we know this is a distance. So if it's a distance, then that means it's only positive, and we don't have to worry about the negative when we take the square root of both sides of these two things down here. So to solve this, so it's positive because it is a distance 89, and there is nothing good about 89. Is 89 prime? It might be. So we would just have to check a little bit, but I'm not going to go do that. But nonetheless, right, I know 81 is 9 squared and 10 squared is 100. So so I can't find anything in between there. So what this is an irrational number. So this is an irrational number. Since it's irrational, mathematics, we like full exact answers, right? Irrational numbers go on forever. The decimals go on forever, never repeating, never terminating. So we won't ever know exactly what this number is ever. It's like pie, right? But it doesn't taste as good because pie is delicious. Yeah, that was a joke. All right. Hope you enjoyed this. See you later. I gotta stop it. Awkward moment. Stop recording.